All right, welcome to the Explainer. Today, we're going to dive into a tool that's honestly a cornerstone of machine learning, logistic regression. So let's jump right in. So think about this for a second. Is an email spam or not? Did a student pass or fail? Is a tumor malignant or benign? I mean, these are all simple yes or no questions, right? But how does a machine, something that lives and breathes numbers, learn to make a clear-cut choice like that? That's the big puzzle we're going to solve today. Okay, so to get to that answer, we actually have to start with something you might already know and talk about where it falls short. We need to look at the limits of a good old-fashioned straight line. So here's the fundamental difference, right? Linear regression, it's amazing for predicting a number that can be anything on a scale, like the price of a house. It just draws the best possible straight line through your data. But you can't really use that straight line to predict a simple yes or no, can you? That's a totally different ballgame. It's what we call a classification problem, and it needs a whole different way of thinking. And that right there is the million-dollar question. If our model's natural instinct is to just draw a line, how in the world do we get it to stop thinking on a spectrum and just make a clear, confident choice? Well, this is where our hero of the day, logistic regression, steps in. See, it has a brilliant trick up its sleeve. Instead of trying to predict a final answer directly, it predicts something way more useful for making that choice. It predicts the probability. And there it is. So, what is logistic regression? It's a type of supervised learning, which just means it learns from data that's already been labeled. But its real genius, the secret sauce, is that it doesn't spit out a yes or no right away. Nope. Instead, it calculates the chance that something belongs to that yes category. You know, like there's a 90% chance this email is spam, or maybe just a 15% chance a credit card swipe is fraud. It's all about playing the odds. Okay, so how does it actually do that? How does it come up with that probability number? Well, it uses this really elegant mathematical trick, a special function that creates what I love to call the magic S-curve. This thing right here, the sigmoid function, is the absolute heart of logistic regression. Seriously, the best way to think about it is like a universal probability converter. It can take any number you throw at it. I mean, -1,000,000, +1,000, it doesn't matter. And it beautifully, perfectly squishes it down into a value somewhere between 0 and 1. And what else is always between 0 and 1? A probability. So let's walk through its job step by step. First, the model looks at all the inputs and crunches the numbers to come up with a score. Kind of like what linear regression does. Then that score gets fed right into our magic sigmoid function. And then boom, out the other side comes a nice, clean probability. So a really high score might pop out as, say, 0.85, which is just an 85% chance. And looking at this S-curve, you can instantly see why it works so well. If that internal score gets super high, the curve flattens out near 1, or a 100% chance. If the score gets super low, it bottoms out near 0. It's physically impossible for it to go outside that range. So then all we have to do is draw a line in the sand. We set a threshold, usually right at 0.5. If the probability is higher than that, we say, okay, that's a yes. If it's lower, that's a no. It's that simple. So right about now, you might be thinking, okay, cool, so it's good for yes-no stuff. But logistic regression is actually way more flexible than just that. It's got a few more tricks up its sleeve. Let's take a look. It really comes in 3 main flavors. The one we've been talking about with just 2 outcomes, like pass-fail, that's called binomial. But what if you have more than 2 choices that don't have any particular order, like trying to classify a picture as a cat, a dog, or a sheep? For that, you've got multinomial. And then, what if the categories do have an order? Think about product ratings, low, medium, high. That order matters, and for that, you'd use ordinal logistic regression. See? Super versatile. All right, so theory is great, but let's get real. What does this look like out in the wild? I mean, how does an actual developer put this thing to work? You know, it's actually way more straightforward than you might think. With a super popular Python library called scikit-learn, you can do this in just a handful of lines of code. For a real-world problem like classifying breast cancer data, you basically just load the data, tell the library you want a logistic regression model, and then tell it to, well, learn. That's pretty much it. All that complex math we talked about, it's all handled for you. And the results? I mean, check this out. When we test our brand new model on data it has never, ever seen before, it gets it right. It correctly classifies tumors as malignant or benign with almost 96.5% accuracy. That's not just a number. That's incredibly powerful. It really shows you how effective this is in the real world.
But hold on. A great grade like 96.5% isn't the whole story. You can't just look at one number. To really understand how well our model is doing, especially for something as important as a medical diagnosis, we need its full report card. Yeah, accuracy tells us how often it's right overall, but we also need to look at precision. When it says yes, how often is actually yes? And recall, of all the actual yeses out there, how many did it manage to find? It's a great reminder that in machine learning, one number almost never gives you the complete picture.
So, there you have it. We went from a simple question, how do machines make choices, all the way to this powerful S-curve that turns raw numbers into probabilities, and then those probabilities into clear decisions. This isn't just theory. This is the engine running behind the scenes in so many things we use every single day. And that leaves me with one last question for you to think about. What's a simple, daily yes or no choice that you just wish a machine could handle for you?